might as well start the stream so I don't forget.
Periodic table,
Oh, yeah, they haven't set up the desk correctly. Set them up correctly.
What?
Yeah, set them up correctly.
Oh, okay.
Let's, these go back. What do we get? We have 3 and 3 in every case. So there's 3, and then the other 3 get rotated. And these are usually moved from the back. That does it good. And then they get tilted.
What else do we sell? We sell industrials.
Let's go back.
Oh, these ones you need?
No, just a single one.
Yeah, just the one.
Okay, I'll mark it on the next time.
And somehow we got an extra one. Oh, that goes outside there. Why is it inside?
Thanks, Brown.
Yeah.
One day.
I don't know. I didn't see any houses.
Yes, he's here.
I'm like your emotional support.
Yeah. Oh, perfect. No, I just do it because
There we
you
go.
mentioned that.
You get ecstatic when you're walking through this. Like I'm not gonna show
He
the
saw
glasses.
you in his
Yes.
I have to leave early for volleyball school.
You really?
You don't have to. You could not volunteer for volleyball scoring.
No, I couldn't. I was forced to do it.
Ah.
Is there a test back today?
No.
No.
I think I realized when you were in the group chat. Well, I didn't realize when you were in the group chat. So.
Ah.
For
This
pieces,
is
you
of course.
said
No big deal.
It's good.
This one?
We have
No.
a guy on our table, so you don't have to.
Oh. Why does it keep disappearing every time I find one?
Yeah, his girlfriend was saying
While we're waiting, go. Rose, head to separate setting. Your test is waiting for you there. Everyone else, grab your lab book.
Where do we get them?
On right to the left.
Can you grab one for me? Please?
Where There's a little there, but I'm mixing with some 12s. Did you hand it in?
I believe, for which lab?
The original lab.
The one with the iron and the aluminum?
Yep.
Yeah, I can that in.
Okay, should be there then. Where is...
Can I run to my house and do something? But I could swear I could.
Um,
Because me and Noah did it together.
have you checked through all of the,
Yeah, I checked through all of them. Let me check it out. Yeah, could I go check my math?
Sure, you can run.
Thank you.
Bro, this doesn't give me not me annoying.
Where the...
Oh, yeah, mine's here. Near hot. What?
Oh, there it is. I told you, it took me a minute to find.
I don't even remember what lab looks like.
This is not everything, right? Except for one.
Yep. My lab
Okay,
very nice.
you have your own lab back. Someone else hopefully marked it. So you should have a mark in there out of 8. Double check that the marker actually was thorough. Looking at someone else's, they were like, great, I got 8 out of 8. And we discovered they didn't have a table of contents. They erased lots of things. Their name and date was on the top of the page. The person was being nice. This is a formative anyway. Your mark is going to be on how you improve on the lab we're going to be doing this week. And so you want to make sure that you're paying attention to all the things and the areas that you want to improve upon. We're going to skip to part 3. I'm going to talk about observations in a table. So you're going to do your own for this part. So skip down to your observations section. Well, first just double check the things that they did, that they were consistent. Your name and date should be in full at the top of every page. Every page that you've used from beginning to end. So if you've used a page and there are empty pages in between, they should still be filled up because it's from the beginning to wherever your last page is. No erasing, single line to cross out mistakes. If they have scribbled on it such to the point you can't read it, no check mark from there. Table of contents has now been created because you've actually started a lab. Page numbers numbered sequentially from the beginning of the lab book. Some people skipped a few pages in and then they started one on like the 5th page.
You told us to do that.
Yeah, I told you to skip some pages. I didn't tell you not to number them. It was very clear, number from the very, very beginning. So if you did that, do something clever, like make the very first page 0A, and the next one 0B, and then 0C, or something like that. So it is still sequential from the very beginning to the very end. Neat and organized, not right up against the edges, that's white space. We can see your different sections, so we can see where the observation section is very clearly, and we can see where the procedure area is and all the different sections that we need, and it has a consistent structure. Going to your observations, all observations should be in a table. And a table at minimum just in a box. You have taken a diary entry and you've put it in a box. It's not a organized system of thought. So the difference between science and a diary entry is science does it with reference to something, so somebody else can repeat it, hopefully, and follow along. So at the very least, if you were just doing simple observations, at the very least, you would do it by time. So 1 minute. Harold blew his nose. 2 minutes. Harold sneezed. For observations of Harold. So you can close it. They should be open-ended. They should have a number. So every single one there should say something to the effect of like table 1. And then the next one should say table. Mari, did you just slip in? Your test is in separate settings. So observations in a table. Tables are numbered. So every single one has a number. If they do, give yourself a check. And then every table has to have a title. Harold's Coal. If such was it. No, there'll be one provided there for you.
What do you mean by numbers?
1, 2,
But
3.
like going down for the observations, or like?
No, every table is numbered. So this is table 1, table 2. The reason for that is in your observations at some point in time, you can then say, in table 5, we discussed, or you can see the observations in table 2, and the reader is very clear as to what you're talking about. The title is also to describe what's in it. So somebody reading your work goes, oh, this is table 5. That's great for reference, but doesn't tell you what's in the table. Sure.
Could I get the marking sheet?
Do anybody else not have a marking sheet? Tables are neat and drawn with a ruler. And this is where I get to say things like, a member of staff who didn't go into chemistry, but apparently originally wanted to, did their first chemistry lab at university. And they got it back, and they go, I think 1 out of 10. Because the teacher just circled things, wrote SP, 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 out of alignment, SP, out of alignment, SP. He was very disappointed. SP stands for spelling mistake. And out of alignment means you didn't put it in exactly the right spot. No, didn't even bother marking the discussion. And he put a lot of work into writing his discussion, figuring out what he did, coming up with sources of error, doing all the things he thought was useful for a lab report. But the teacher was only focusing on these things. One of the things I want to do is make sure you get to university and that doesn't affect you, because we're going to treat it with the contempt it deserves. It's not hard to do this, but you probably haven't done it before, so I'm going to focus on this right now so later on you can do observational things. And in first year, I'll get your question in a moment, the teachers don't care about your observations because you're like little baby kindergarten people. The lab is not useful. It is purely to teach you how to communicate for when you do real labs. And that will be the first year teacher's perspective in many cases. So they're giving you something to see. Can you spell correctly? Can you put things in a table? Were you taught? And they'll be very dismissive of your high school experience because obviously you weren't taught anything correctly and they have to reteach you. If you've had any experience with it at all, you'll be fine. Even if you're not fine, I got 2.5 out of 10 on my first lab, so at least I did a little better than he did. And most of my mistakes were this. What did I do wrong?
It's not a perfect square.
Perfect square. I got so paranoid. I took drafting in high school. I used a drafting technique where you take a piece of paper and you just carefully, and you take a eraser, you go like that, and you pull it away. And oh, it looks really. Draw it with a ruler. I'm not going to be that pedantic, but sometimes I want to look good. You might do handwritten labs. You might do labs on Word. They tend to like an actual program rather than Google Docs because timestamped, and we can make it so you can't change it afterwards. You just update the file in that kind of manner. I don't have a bunch of grad students at my beck and call to do that for me and monitor that and everything, so we'll use paper. And some places still use black paper, in which it is copied onto a separate sheet every time you write. You just put in double copies, and that way they can double check your work. So, we're, mostly what we're going to focus for this one is neatness, and then after that we can start looking at observations and things and see what we're actually doing. And the lab should be fun as well. So, tables should be neat and drawn with a ruler. If you did that, give yourself a check mark. Observations do not overflow lines. So when you arrive to observe Harold, you could pre-do the first table. Table 2, Harold's nose. And you'd set up time. Harold, you have made your observations. You might draw these lines, and then you'd stop. And then you write 1 minute, and then you go da 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 da, and then you stop because you're done the minute, and then you write 2 minutes, and then you'll take your and you'll draw your line to there. And it's perfectly filled. You don't have a lot of space. If you pre-drew this, you might have pre-drawn it there, and now it's overflowing, which is what that's referring to. Or you pre-drew it going, I'm going to take a ton of observations about Harold's nose, and there's just all this blank space there. Don't pre-draw it, unless it's something you absolutely know the amount they're going to do. If it is 1 minute, and Harold's snot, and you know you're measuring it in milliliters, then at 1 minute, 10 milliliters, 2 minutes, 15 milliliters, and you know that that's all the data, then you can pre-draw your entire table because you know the size of the numbers that you're going to do. But many of our labs are going to be observation labs. So do not overflow nor underfill. You did that, give yourself a check mark. Observations are complete. There's nothing that leaves you hanging there. You go like, what do they mean by that? If you're using vernacular or shortcuts that other people wouldn't know and aren't standard, then you would have to explain them in a key. DNA is known, but NRG is not. And it's organized logically. You have some columns that has organized the data with some. The lab we are going to do is acids, bases, and indicators, and I've given you the tables, and so as you go through, you'll be able to grab them, look at them, and then make them up with the data as it's shown. Nice little not right now, next day. You have a pre-lab to do first. Do you have your laptop? Grab it. Oh, you never had one in? For the lab? Ages and ages ago?
He wasn't here.
No?
Very day.
No, but there was labs after that.
There was.
Yeah.
What lab was that? Because I was here for that too.
John Williams, doesn't pick the credits. Jojo. Whose is this one? There's one more here. Oh no, that's Isaac. Maybe you did not. So, just make, I'll give you a copy of the marking sheet. Because when I take in, I'm looking at both labs, the original and this one. I'm looking at your improvement. Okay?
This was. Do we have more labs
We did one at the very, very beginning of the year when we partnered by
Yeah,
State.
I have
Yeah,
that one.
yeah. Yeah, so this will be our third. And going through, we're gonna do this last section not as a thing I'm gonna give you a test afterwards. The lab is the assessment for this last area. We're gonna do S's and bases, a little bit of periodic table, some demos to go with it, and then we're on to biology. Don't worry, if you're like, oh, I can come up with a chemistry lab for every single unit. Because everything is chemistry. I mean, the physics one might be taking beakers and throwing them against the wall,
That sounds fun.
but that's
We should do
still
that.
technically chemistry.
We should do that.
So, put that away. Now, other things I look at, of course, is did you do your pre-lab? Do you have your observations if we were going to do that? Keep the marking sheet. When I get your lab book in, I'm going to be comparing your first labs. I'm going to be comparing your next one, looking at the improvement, and then you'll get your first ever lab mark because the first one is always a formative. Do fix, however, anything that was missing that refers to your whole lab book. So page number sequential. If you're writing in pencil, switch to pen. Name and date on the top of every page as you go along. And put in your table of contents so I can find your different parts of your lab. Now, to the pre-lab. Pre-lab. Instructions. There we go. Okay. Number one, read the lab. Write out the purpose of, not right now. Write out the purpose of the lab. I want you to create a diagram for each section of the lab. For parts 1A, B, C, and part 2. So you don't have to draw it for every step in each part, but something that would show you what it could be. So for example, I think I linked it. Grade 12s are also doing a lab. Did I put one in here? Yeah. So if you're drawing it, load, there we go. You may draw the bottles you're going to use, so essentially the reagents and the chemicals, dropper, what you might do, so drawing it in. Now, that looks very nice and neat, and you may be saying, Mr. Neufeld, you cheated because you drew that with a computer, and we have to draw it in our lab books. And yes, I am not very good as an artist. My biology, I didn't go too far into the just animal section of biology because my biology professor said my drawing of a mosquito proboscis made it look much, much sicker than it needed to be. It is a long-standing part of, both biology and, I erased all those. I have two of them open. There we go. And biology, to be able to draw. So in the field, being able to draw animals on your equipment, it is very normal to sketch out your reaction apparatus. You have your lab itself, and some teachers, what they'll do is they'll just say, write out the entire procedure in your lab book, and that way you have to go through it line by line. And you might be different than me, but I find I can write things that without remembering anything. It's like a skill. So if I was to draw it, part 1A, you don't have to be perfect. I am going to probably be messier than I would if I sat down and did it and took a little bit of care. But let's see. Obtain 5 mils of solution A in a test tube and 5 mils of solution B in another test tube. So that would be... Don't know how to draw 3D. Solution A. Solution B. Obtain 5 mils. Use care with these chemicals and wash any spills immediately. Using a medicine dropper, place a drop from test tube A on a piece of red litmus paper. So, and recording color change, use the same medicine dropper, place a drop from test tube A on a piece of blue litmus paper. Recorded in color change, rinse the dropper thoroughly with water. So in its simplest form, it can just be all of the materials that you're going to use in that particular part. You've labeled everything. If you are artistically inclined at all and you want to draw someone actually doing one of the parts, like swirling the flasks, if it tells you to swirl the flask, great. If you are just going to draw the parts as best you can and label them, great. That way you have a visual representation of what you need to do. You've had to read it and interpret it and figure out what you are going to be doing in that section of the lab. That is a hugely invaluable practice. When in university and onwards, if you ever have to do something, drawing out a little cartoon of every step, I always found particularly helpful. And my skill at drawing is awful. Okay, so one section for each part. That includes part 2. If you haven't seen part 2, flip it over. You are going to, once you go through part 1, do 5 unknowns and figure out which are acids and which are bases. I have given you the tables. Oh my goodness. I even gave you the titles of the tables. Half the time I leave a couple blank to see what you come up with as part of the process, so I've been extra nice. Don't, again, write them all at once. Just do table number 1 to get ready. But you have them here for reference when you need to quickly set them up. Bring a ruler. When you're going through, part 1A is the red litmus, blue litmus. You do phenolphthalein. But then all of a sudden you go to mixing. And then you do the zinc test and you go back to the first table. So they're not quite in time order that you do them. They're in an organizational order, so you have the acid test and the base test in one section so that you can use it when you compare it to the unknowns. Any questions? Okay. In that case, let's just double check. I think there's one more thing on the pre-lab. Oh, that's not your lab. That is a nice lab, but that is not your lab. So, read the lab, write the purpose of the lab, create a diagram for each section. You do not have to write out the whole procedure. You're going to have the procedure in your hand and you're going to have the diagrams. Put in your observation section and then start the first table. Don't make the entire table. There are examples tables there. So pre-lab, diagrams for each part, answer the pre-lab, purpose, observations, first table, start. Put away the lab. Put it away, that's prep. I'm not going to give you any other prep today. So tonight's prep and tomorrow's prep, theoretically, put it away. Pardon? No, you keep it. I'm going to take it in when you do the next lab. So you have to have the pre-lab done when you come to the lab, because that's what I'm going to check. Yes? Right here. what ion does an acid release, and what ion does a base release? Yep. So it's all written on the Google Classroom. It's all there. Okay. Pull out your data booklet and turn to this page. Yeah. And there we go. Okay, turn to this page in your data booklet. I have so many data booklets. Yeah. Okay, then the first question is then, where did I put them? But yes, because we just wrote a test and I have all those data booklets.
So much paper.
But where did they go? Oh, here they are. Who wants a data booklet? It's like water, they just flow through the classroom.
When will we get our test?
As soon as I'm done marking them, they have to be marked this week. The grade 12s wrote their test first. I just finished marking most of that one. Yours is next, and then I'll put it up in zip grades because it's done, so you check that as well. And then you'll have it. Do you get your percentage mark now that you have access to the grade book?
No, we get a letter grade.
If you look at that and you're like, it didn't change, did my percent change, just come see me and I can give you the exact percentage. I don't mean to make fun, but I also found out something new. I'd forgotten that you can see the grade books if someone said, my mark went down. And I said, yeah, you wrote that quiz you did terrible on. And they were like, yeah, but it doesn't count. It doesn't count when you do better on your test. And they're like, oh, before you couldn't see it, so you never saw it go down and then go up because it becomes formative later. And so then it could improve and could greatly improve. Okay, you're on this table. We're going to talk about acids and bases. This is the last section of that, and we're going to just a little bit of periodic table review in terms of what the alkali metals are. But I want to talk about pH. It's a little bit different a measuring system than what we've seen probably in other areas. Where I just had those pieces of paper. There we go. To remind myself of what I say. Number one, acids over here have a pH of less than 7, and bases have a pH greater than 7, and neutral, right in the middle, is a pH equal to 7. So neutrality is 7. And that is not an arbitrary number. That wasn't picked to be 7 because they wanted it to be 7. It's not like 0 degrees Celsius was picked to be 0 because it's the freezing point of water, and that was just handy. The freezing point of water is 0, it boils at 100, so in Celsius, we made that our two, 0 and 100, and we just did everything from there. But it's arbitrary. You can have negative numbers. And it goes, there is an absolute 0. Does anybody know where that is? Does anybody know where absolute 0 is in Celsius?
Like minus something.
Minus something.
Yeah.
Yeah. You can't get colder. Like there's an actual 0.
Isn't it like Kelvin though?
Well, the system that measures using the absolute 0 is Kelvin. So 0 Kelvin is absolute 0. 0 Kelvin is negative 273 degrees Celsius. When you think about the ranges, it's not that cold. In the sense that, boiling's plus 100. You can get to 2,000 degrees Celsius with like a but minus 273. You know, few hundred
Can you
Celsius
guess
near
what
it,
temperature?
absolute zero. You can't. You can get really close. We've gotten within thousandths of a degree of it. At that temperature, everything, because temperature is energy of motion, at that temperature, everything stops moving.
What about we stop moving?
If you moved, it's not absolute zero anymore. Because temperature is a measurement. So even the electrons would have to stop moving. There'd be no vibration of any particle at all. Zero movement means zero movement. And electrons, those things can't stop moving. So it is actually impossible to get there. If you could get there, there's a number of physical laws that you could break. It is fundamental to physics and chemistry that you can't actually get to absolute zero. You could break some laws of conservation of energy and mass, for example, if you got there. But we can't seem to get there. It's a bit like the speed of light that you can't get faster than. Yeah.
Would the water in your body freeze right away?
I don't know how long, if you were put into a freezer at absolute zero, first of all, the freezer would no longer be absolute zero. However, it'd be very cold. You would freeze quickly, not as quickly as you'd think. We've gotten liquid nitrogen out before for the grade 11s. You put a balloon full of water in it, and it freezes, and then stops freezing for quite a long time. Why? What is the property of water that protects the liquid water?
It's insulated by the ice.
Yeah. So once you form the ice layer, it protects the rest of it. That's why that's why when we look for other planets and will they have life, we look for water. Not because we're just prejudiced. I mean, we know that we're water-based, but water has this unique property that when it freezes, it floats. Most things, when they get solid, sink. Then they get denser. Ice is weird. It gets lighter. So it floats. That performs a ice layer, which is an insulating layer that protects the rest of the pond. So if life is going to develop, then when the planet gets cold, it needs somewhere to hide. And that provided a place to hide for early life and current life. So, yeah, water's a pretty interesting thing. Yes?
Can like your blood freeze?
Yeah. Oh, well, you can literally freeze. If you look at pictures of people who've climbed Mount Everest, there's a few stops along the way of people who are frozen because they just stayed there. Yeah, too much work to take them down. Some markers are just literally bodies. Yeah. One of the problems with one side of Mount Everest is getting the amount of trash because nobody wants to take anything down, and that includes human remains. This is starting to get a little depressing. So we're going to move on. This scale is also unlike any scale. 7 is neutral. 6 is 10 times more acidic than 7. 5 is 100 times more acidic than 7. 4 is 1,000 times more acidic than 7. 3 is 10,000 times more acidic than 7. 2, 100,000. 1, a million. So it jumps by a factor of 10. So it's not just like, oh, it went from pH of 6 to 4, like it doubled. It didn't double the acidity. It increased it by 100 times if you jump 2 spots. So it's quite a bit more acidic. Also, someone pointed out, all of these things you could eat. Don't eat those things.
You can eat apple.
No, I said don't eat those things.
But you circle the. You didn't
Oh,
put the line
well, it's because of, obviously, well, you shouldn't eat raw stomach with the stomach acid still in it. So I assumed don't eat that.
Well, but.
Also, okay, don't eat that. I mean, theoretically,
Oh, okay.
theoretically, you can eat soap. Many a parent in the past has washed some child's mouth out with soap. It is technically edible. Not very good for you, though. Definitely don't eat Tide Pods. These are very, very dangerous. If you drink bleach, there's very little they can actually do for you. These are quite basic. Basic has a way of just ripping chemicals apart, as particularly organic ones. And lots of poisons are basic. And so the basic things taste bitter. you have an instinctive reaction not to like it. You have to get used to things that are bitter, like coffee. But things that are sweet often have citric acid and as well, and so they can be sweet and sour. And lemons, I mean, you can take a half a lemon and rub it on a counter and clean with it. The acidity will actually take off a lot of the dirt and grime. Then you have to clean out the sugar. But it's really acidic, and lemon is used in a lot of cleaning products. Yeah.
So would stomach acid be sweet?
Stomach acid would not be sweet. I said fruits were sweet and sour. The sweetness comes from the sugar. The sourness comes from the acid. So acids are sour.
So stomach acid would just be really
It
sour.
would be really, really sour.
Can it melt milk?
No. Well, it can rust it. If you vomit on your parents' night's carpet, clean it up right away because acids will affect the dyes in the carpet and they will permanently stain it for a long time and start to eat away at the fibers. Your stomach acid is quite strong at a pH of 1. It's used as part of the physical digesting process to break down all the tendons and other things that might be in the food and the fibers, like the silly things that are in celery. And in addition, it's good at killing a lot of the bacteria that come in. So bacteria that survive that process that can infect you have a method of protecting themselves from an acidic environment. What else should I mention? Now, I said this isn't arbitrary. pH of 7 is neutral. This is 10 times more acidic. 8 is also 10 times more basic than 7. 9 is 100 times more basic than 7, and so on and so forth. No one has pointed out a key problem. What is the problem in saying 6 is 10 times more acidic than 7?
Because 7 isn't acidic at all.
Right, and that is often a conclusion I found students made in grade 10, and that's why I want to emphasize this point. 7 is acidic. It's also basic. What it is neutral, which means there's an equal amount. So this graph here is a logarithmic graph for the amount of acid and the amount of base. At 7, we have the amount of acid is equal to the amount of base. And acid is H+, and base is hydroxide. Those are the two chemicals that mean one or the other. Yeah.
That, what actually is base?
Hydroxide. Like it literally is hydroxide.
So if you just had hydroxide, it would be.
It'd be base.
14.
Well, now again, you don't find these things alone with a charge. They're too attractive. So, a very common base is sodium hydroxide, otherwise known as lye. A very common acid. Give me a common acid. Any acid?
Citric acid.
Oh, yeah, one I don't know the formula of. Actually, C6H12. No. I can't do the. Any other acid? That's base. That's the base. Acid. Stomach acid.
Stomach acid.
What is stomach acid? Oh, I'm glad you said stomach acid. It is HCl. HCl goes to H plus Cl minus. NaOH goes to Na plus OH minus. So base is hydroxide. They have an equal amount. How many of you have done scientific notation in Math 9 already? Excellent. So if I write here 1.0 times 10 to the minus 7, that won't freak you out too much? Excellent. What is 1 times anything?
No, it's no.
Yeah, 1 times anything is not 1, but the anything. Right? Right, okay. 1 times 7 is not 1, it's 7. So rather than saying 1 times for all of these, I'm just going to say that's 10 to the minus 7. That is how much acid is in there. The amount of H plus at 7 is 10 to the minus 7, or 0.1, 2, 3, 4, 5, 6, 7. That's how much. It's a very small amount. And there's an equal amount of base. Whereas here, it's 10 to the minus 6. is that number bigger or smaller than 10 to the minus 7?
Bigger.
Bigger. So that is why when we measure pH, it's becoming more acidic, but the number's going down. But it's going down because this one's 10 to the minus 5. What would you guess that one is? 10 to the minus 4. So now you've just discovered the numbers in the pH scale. 10 to the 0. There's nothing special about 0 in this case. You can have 10 to the 1, in which case you can have a pH of -1. The pH scale goes off, and it can be above 14. You just don't often get acids that are that strong, but you could.
What would be like an acid that's that strong?
Okay, so this is 10 to the minus 7 is 6 zeros, and then the 1. So 6 zeros, 5, 4, 3, 2, 1. No 0. So this is 0.1. This is 1. So 10 to the 1, that's just 10. Concentrated sulfuric acid is about 28. So that can do that. But concentrated is, the sulfuric acid is so strong it pours like an oil. And you cannot make it stronger than that because there's no more will dissolve. The water is completely saturated with sulfuric acid. So you can't, minus 2 or 100, you just can't physically make. Yep.
Can that just like melt through anything?
No, lots of things are resistant to acid. Like you pour it in a lot of plastic. Have you seen Breaking Bad? When he gets acid to dissolve a certain something, and it dissolves its way through the tub and like goes to the floor. That's because it reacts quite well with metal. He's not even using a strong acid. Hydrofluoric acid isn't strong. It's just incredibly reactive. It reacts with a lot of different things. That strong of an acid, put it in a glass bottle, it'll sit there forever. It doesn't attack glass. But stick your hand in, it'll turn it into a crisp. Slowly, like you'll watch it turn black.
How long would that take?
To fully dissolve your hand, hours and hours and hours, because your bones would take a long time. But it will hurt the whole time until all your nerves are burned away. So it'll hurt probably for 15, 20 minutes. And then it'll get through all your skin and flesh part.
And then it'll feel like
And then you'll just watch as all the red tendrils come off and pass that part. Pleasant. Yes.
So does it mean how much acidic it is like how much? It's just like the more hydrogen it has.
The more hydrogen it has, the more acidic. And this scale is a hydrogen scale. So this is becoming more basic because it's getting less and less hydrogen. So this is 10 to the minus 8, 10 to the minus 9, 10 to the minus 10 amount of hydrogen. The amount of base here is 10 to the minus 7. The amount of base here is 10 to the minus 6, 10 to the minus 5, 10 to the minus 4. So base is going up while hydrogen is going down. They exist together in the water. Yep.
What makes hydroxide specifically what makes a base? Why isn't it like anything else with?
I can answer that, but I'm not going to. Chemistry 12, I'm not going to tell you. Okay. Excellent. Moving on. Well, because to tell you, I'd have to just reveal how I just lied, and I let your Chemistry 12 teacher do that.
So what's even like acidic? Like it just means that it's highly reactive. Is that like what acid you use? Or like what?
No, acid means it has H+.
Yeah. Like,
So you can have a strong and weak acid, which I'm not going to go into because, again, that's Chem 12. And for the purposes of Science 10, we assume all acids are strong acids. But like something like vinegar is known as a weak acid, but it still has a anyway. To fully talk about it, I have to teach you about something called molarity, and because I just said it's 10 to the minus 7, and nobody has said 10 to the minus 7 what?
Moles.
Yeah. Yes.
Are there like similar things to acid that don't have hydrogen? Like,
No.
The same properties?
No. Acids are H+.
They have them?
Yep, they have. That is what an acid is.
What about like corrosive things? Like
Oh, there's things that corrode, but they're not acids.
there's no other things that can melt your hand.
Oh, you could oxidize it, which would burn it, but like it's not an acid at that point. Yeah. Okay. The next part is that you are going to play with some indicators. Litmus is a very famous one that you're going to use. You're also going to use phenolphthalein. Phenolphthalein, notice, doesn't change color until it's quite basic. It's got to be up here in pH of 9 before it'll start to turn pink. There are a variety of indicators that will change color at different pHs. Methyl orange is red in acidic solutions. In neutral or basic, it is yellow. Methyl red, you can see, is red a little bit longer. And so you get different color changes at different spots. If you turn to the first page of your notes, at the very bottom, you'll see a strip. This is universal indicator. And what you do is you mix a bunch of those indicators together, and you can get one solution that will change color throughout the regular pH scale. So if it's deep red, you know that's really acidic. If it's deep blue, you know it's basic. But if you get in the green, you go, oh, I'm around neutral. Light green 6, dark green 8, light blue 9. We're getting into the beginnings of orange 4, 3-ish, getting to 2. So the color scale will actually tell you how strong it is. It's called universal indicator. There is no one indicator that will do that. All of them have single or double color changes. There are a few that will go like red, yellow, and then it might have blue on the end. Like you can get 3 colors out of some. But we don't get the rainbow. We made the rainbow by putting together a bunch of indicators and making a solution.
You said bitter things are from bases, and you use coffee specifically as an example, but it says that coffee is
Coffee is acidic, but the flavor compound for coffee is a base. Coffee is made of a complex amount of chemicals. There's a lot of chemicals in coffee. Have you ever known someone who will like drink a cup of coffee at 10 o'clock and go to sleep? Yeah, and it's like, how do you do that? And by the way, that doesn't work for a lot of energy drinks. Caffeine wakes you up, but there's way more than just caffeine. Caffeine itself is a base, and the caffeine itself will taste bitter as well. And that's often what they're trying to mask with all the sugar in an energy drink. But coffee also has sedatives in it. So if you get used to the caffeine, coffee can make you sleepy. And so there's a ton of things in coffee other than just it. So its pH is acidic, but a lot of the flavorings are bases, and you taste those. Yeah. Okay, we're now going to write down all the things I said. And I will try and keep this part consistent. Acids have a pH of less than what? 7. And bases have a pH of more than 7. What's neutral? What? Equals 7. Nice. Acids give off. What ion do acids give off? H+. So HCl is an acid. Goes H plus to Cl minus. That might look like a decomposition if you called it that in a test. I wouldn't object. But this is also a process known as ionization. Because you just put HCl in water. If this is a gas, it's not an acid yet. You put it in water, and it becomes aqueous, and then it's an acid. But is hydrochloric acid covalent or ionic? Why is it ionic? Is it metal or non-metal?
non-metal.
Non-metal, which would make it.
Covalent.
And if I look at the structure of HCl, if I said draw me the structure, you would go, oh, hydrogen has a valence electron, chlorine, the 7, they join, and then you get HCl. Is that structure covalent or ionic? Covalent. There's no charges in that. So it exists uncharged. It is a covalent compound. But if you put it in water, water rips it apart, and it becomes charged. So that's why the process is called ionization. It makes an ion.
Of course.
Yeah. Because everything I teach you eventually becomes a lie. One of the reasons I love, and one of the reasons why I absolutely hate chemistry, is because you go into biology and you get to learn a lot of names. There's more brand new words in biology 11 and 12 than there is if you're learning like French or Spanish 11 and 12. They have more words than learning a new language. Because you have to know what a zebra is, and what a zebra's foot is called, and what the veins in a zebra are called, and all the different parts to even talk coherently about the biology. So there's just a lot of words. But if you're good at memorization, biology is easy. Physics doesn't have a, I mean, how many ways can you describe I threw something and it went up and then it went down? There's not many new things in physics. But they have a lot of formulae. They do a lot of calculations. What does that parabola look like when you throw it? And how fast is it going to come down a different price? So there's a lot of calculations. But there's not a lot of exceptions. Those calculations rule in many cases. So if you're good at math, you're good at physics. In chemistry, there is a rule and about 1,000 exceptions for everything, because how something reacts as you go across the periodic table subtly changes depending on the structure of the atom. And the atoms change as you go across families. They're not identical down families, and so you get all these weird exceptions. It is both makes chemistry really interesting, and when you're trying to get something done, really frustrating. So there's a strong acid. Hydrochloric acid, this is what's in your stomach. And if you want to know the difference between a strong acid and a weak acid, I could have, like I told you, you could have a concentration of 1, which would be a pH of 0. You can get HCl to a concentration of 1, it would have a pH of 0. If I made it a concentration of 1, that acid, acetic acid, is a weak acid. It would not have a pH of 1, but it would be able to react with the same amount of base. And its equation would actually look like that. And that's all I'm going to say about it. What do bases give off?
Hydroxide.
So OH minus, hydroxide. So classically, NaOH goes to Na plus. How many of you have seen Fight Club? He makes soap in it using a product called lye. Lye is just an old term for sodium hydroxide. Sure, yeah.
What's that subscript after the nitrogen?
Oh, that's Na. It's not nitrogen, it's sodium. So sodium hydroxide, metal, non-metal, so we know that's hydroxide. We can have calcium hydroxide. That's a hydroxide. And I don't want this to be a trick question, so I'm going to tell you the answer right away. This is not a hydroxide, this is not a base. Why is that not a base? It doesn't give off hydroxide. It does have an OH there. What kind of compound is it that is unlike the other compounds? Which one of these is not like the others?
It's organic.
It's organic. In addition, so what kind of bonding does it have? Covalent or ionic? This is covalent. This is ionic. So ionics have hydroxide because hydroxide is an ion. This is not an ion. That's an alcohol. And I'm really glad that none of you recognized it, because of course you wouldn't recognize alcohol because it's poisonous to you until you're 19 years old in the province of British Columbia. If you have but a single drop, it will destroy your liver and you'll instantly die. It's really dangerous if you're like flying. You could be over Alberta, and at 18 you can have a drink, and then as soon as you fly into BC, instantly dead. Just happens. Yep.
Is that how like people used to make like illegal alcohol like new chats stuff? They just combine chemicals.
That's the hard way. The easy way is with biology. And biology means that you go and you get some fruit and you mash it up and you just let it ferment and the yeast will make it, yeah. One house did find a boy had tried to, sorry, that gives away that it was one of 4 houses, tried to make essentially prison alcohol, which is where you get a bunch of fruit, you mash it in a bucket, and then you leave it until the mold grows over top and it's got a nice cap there and then it ferments underneath and then you just drain it out. It's like, at that point just get fake ID like everybody else. Like, what are you doing? That's just sick. Do not drink alcohol, by the way, in the lab. And I don't mean like don't bring in a beer. Like obviously you were not allowed to do that either. But like, you'll see bottles in there that might be just labeled alcohol. And it might have another chemical name that you might not recognize. This is ethanol. This is drinking alcohol. If you drink this, it is mildly poisonous.
How high proof is it?
In the lab,
Yeah.
it varies. To make drinking alcohol, every part of the alcohol has to be safe. So the stuff you buy in the store is made with like fruits and watered and filtered and stuff. In the lab, to make cheap alcohol, they distill it with hexane. So it is, say, 98% pure alcohol and 2% hexane. Hexane is a class 1 carcinogen, which means it is amongst the most cancer-causing chemicals known to humankind. Do not drink it. But let's say, even if you did, you grabbed a different bottle that also said alcohol, because this is ethanol. This is methanol. When your liver processes this, it takes that and turns it into, see the 2 carbons? It turns it into these 2 carbons, adds an extra oxygen, because your kidneys actually have a really hard time getting rid of alcohol, so your liver turns it into vinegar, which is what that is, and then your kidneys can grab it and get rid of it. The charge makes it easy. Methanol gets turned into formic acid instead of vinegar, which is known as antibite, which is a nerve toxin. So if you drink methanol, first you'll go blind, and then it'll kill enough of your brain that you go into a coma and die. It is far more toxic than ethanol. And the lab has hundreds of alcohols of varying degrees of toxicity. So if you were to steal alcohol, don't steal it from the lab, steal it from your parents' liquor cabinet like everybody else. And I'm not telling you to go steal from your, I'm not like that, but
Oh, that's a good idea.
safety-wise,
I should try that sometime.
that is actually much safer because at least that's not poisonous. Yep, go, Grayson.
Oh, how much ethanol can I drink before like dying?
Oh, none.
And what would happen?
Since you're under 19 in the province of British Columbia, you would instantly die.
What happens if you drink it?
If I drank it,
Yeah.
I don't like alcohol. Like seriously, like I don't drink alcohol.
No, but what would happen?
I would go, yeah. You'd have to make me drink it, like
How
eating
much-
broccoli.
What's like the lethal ratio?
I don't know. You can look up the LD50 online. One of the reasons we know that, have you heard that alcohol is a depressant? That doesn't mean that it makes you depressed. I mean, it might, but that's not the reason. A depressant means that it causes a decrease in the activity of nerves. So your nerves slow down. One of the areas it affects that it decreases the activity of is your coughing reflex and your breathing reflex. So one of the ways you die from alcohol is you pass out, and while you're passed out you throw up, and then you choke on the vomit. But because you don't have your coughing reflex, it's been depressed, you don't cough it out. And then, because your breathing reflex is also suppressed, you just stop breathing. So if you see someone who is passed out, and you were all old enough to attend an illegal party that you should never attend, you see someone passed out, what do?
Turn them on their side.
You turn them on their side and you call 911. Seriously, people at university in the first year, you get people who have never drank before in their entire life, they go to university, they don't have their parents, and every year somebody dies because they just drank too much their first time, and nobody called 911. If you're in doubt at all, call 911. You're not going to get in trouble for helping someone else's life in Canada or the U.S. There's Good Samaritan law.
In the acid, shouldn't that last hydrogen be positive?
Oh yeah, it didn't come through, or I didn't draw it. One of the two. Thank you.
And also, if there's methanol and ethanol, is there like
Butanol. There's butanol. There's pentanol. There's Penten 113 trial. Like there's now you've done a little bit of organic chemistry and you start seeing how the naming goes. Well, look where I put the B. I just had. There we go. Other properties. You are expected to know the properties of acids in terms of how they react with the litmus paper. Litmus paper, you have this on here if you need to look it up. But litmus paper is a very cheap, long-standing, because it changes right at pH 7. You should know that litmus goes red for acid. Huh? You're frowning. That's clever. No, it's not clever. And then litmus turns blue for base. Huh? You're off now? Okay. What time is class in? 9:30? What other properties we need to know? We need to know that acids taste sour. Bases, yes? What's the block right now? E. So F is next. It's always in alphabetical order with whatever one you start. So if you start with F, then the next one's going to be D and then E.
Do you know that alphabet?
Bases taste bitter. Acids will sting you if they're concentrated enough right away. Which, if I'm dealing with an acid, I go, ow, like it's a warning sign, like it burns. But bases, the scariest feeling I've ever felt, bases feel slippery. Yeah. Because I've accidentally gotten some in my hand, and then I go like this, and it's like there's soap there, and I'm like, holy shit. And I run, sorry, I just swore. I just realized I did that because I was remembering the time. I apologize. Ran to the sink, washed it all off. The reason it does it is a base plus fat makes soap. So it is taking the membranes of your skin and literally dissolving it into soap. So when you feel this, your skin is literally melting away and turning into soap. So you need to get bases off of you right away and quickly. Now, the bases we're going to work with aren't that strong. That was I was working with 6 molar, so a pH of 14.5. So it would rip my flesh apart fairly quickly, and I was stupidly not wearing gloves. Yeah.
Could you like make a slip and slide out of bleach? Like would that work?
Out of bleach?
Or like one of the bases.
that
Would it not
turns
like
into soap?
Because it makes soap.
It is slippery, yes, but as you're sliding, you're going to turn into the soap. And I said acid sting. That will hurt once it gets to your nerves. So it would be a very painful slip and slide. But technically, yes. Yeah, like I think you just came up with a supervillain slip and slide. Like, what is it?
Or like a water.
Well, Bond,
It's like-
today we're going to have you escape from the slip and slide.
Let's not like put it at some shadow birthday party.
Common things you find acids in, these are fruit juices. Coffee, poisons. And it's not just that poisons are bitter because there are acidic poisons, but some point in evolutionary history, a lot of the majority of poisons would seem to be basic, because once animals determined that basic things might be poisonous, they stopped eating them. So then a very common defense is to evolve a poison that's basic, because you don't want to be delicious and poisonous. That kills you and them. No benefit. If you are bitter and poisonous, and they spit you out and they don't eat the whole plant, that's an advantage. Coffee, caffeine is bitter because it's poisonous. Humans drink it because we're insane. Ooh, this make me go fast. I drink and then we take the capsicum out of hot peppers and deliberately eat the poison because it tastes spicy when burned. It's a warning to the reason birds eat it, because they can't taste capsicum. Their mouths don't get hot when they eat berries. So it's to ensure that the fruit is only for the birds, and that other mammals who don't spread the seeds don't eat it. I don't know. Yeah. So like humans, we're large and we can get away with eating some poisons, and then we decide to turn it into food.
Can you overdose on coffee?
Oh yeah.
Like that?
What about
Yeah.
coffee?
You can overdose on caffeine.
On caffeine, yes.
You can overdose on
It'd take a lot of coffee. Basics. Baking soda. Here's one that technically you can eat. So baking soda is basic. Ammonia, don't eat that.
dirt, kind of.
And soap. I said bases with fat can make soap, but soap is also basic. So soap is a type of base, which is why soap tastes bitter.
Will soap really slowly turn you into soap?
Technically, if it was strong enough, yes. There are harsh detergents that can. Yeah. Because the purpose of soap is to lift off fat. Your skin is all fat. Last one, and you asked what a base was. All acids are H+. What are all bases? OH. Ammonia, what's the formula? NH3. And that is a base. And no, I will not be taking further questions.
It's negative.
There is no hydroxide in that, but it's still a base. We're going to do the periodic table next, but I think now it's time for a little bit of a demo. I'm going to go set it up. What I would like you to do while I'm setting it up, write out what you can remember. What are the properties of metals and what are the properties of non-metals? Caffeine may go fast.
I once drank like two 16-ounce coffees at work, and they had like 3 shots of espresso in them each. And I'm like illegal, or not legal. Sorry. Okay, a healthy amount for me is like 1 shot of espresso. And I drink 6. Hey, 6 times the healthy amount of coffee.
I don't do drugs. I assume you're talking about drugs when you said I don't do drugs.
At least,
Is alcohol a drug?
Yes.
Okay, come along.
Matthew is the best I get to look forward
It's just
while
moving
you
on.
see that Matthew in his face.
I feel like they don't care though. We were feeding for it.
35.
You're like nice.
I'm just trying to figure out.
Hey, was I good, Cox?
I mean,
Does it need to have a hydrogen?
nope. I mean, you kind of around it.
I'm gonna figure this out and then I'm gonna like send
Oh. So, rest of the demos, properties of metals, and some properties of... No! Next day, lab. Hold it. Our next day today is Thursday. So, probably just, Fridays, Saturdays classes are short. On days that we have long classes, half of it would be lab, half of it no. But we're on Saturdays, so we'll see what we do. Come prepared. You need to have your pre-lab done before you can do the lab. So if you could grab those.
I'm all told I can see you later.
Is anybody in either Rose's or Mari's house? Yeah? Oh, they left their bags here, so they'll be back. Never mind, I was going to say, can you take those away? But